Hello everyone, I am Bashar. Welcome to my channel TechQuest Learning Point. Today I am going to start a new tutorial about Microsoft Azure Data Fundamentals. It's my mission and a great passion to make difficult concepts easy to understand as much as possible. This is the first episode of the complete Azure Data Fundamentals series. I can assure that this tutorial will help you prepare for the Azure Data Fundamentals certification. In simply, this tutorial will help you to clear the exam DP900 Microsoft Azure Data Fundamentals. This tutorial is meant to give you a good start into the world of data. We know that the Azure Data Fundamentals certification is required for achieving the Azure Data Administrator Associate certification. Before starting the tutorial, let's look into the contents of this tutorial at a glance. In fact, data powers the digital transformation that is sweeping across organizations and society in general. In this tutorial, it covers the various topics related to the core data concepts, including common data formats, options for storing data in files, options for storing data in databases, characteristics of transactional data processing solutions, characteristics of analytical data processing solutions. Over the last few decades, the rate of data generation has increased significantly in many ways from many sources. 2.5 quintillion bytes of data were created every day. But how much is really 2.5 quintillion? It's 2.5 plus 17 zeros. The base is growing exponentially. Most of the data we have today was created in the last 5 years. Data is the very basis of knowledge in the world. In our daily life, we are generating huge data and then working with data to produce a result. We cannot imagine without data. In our business, we have many tasks related to the data, such as creating new data, collecting required data from various sources, processing the data, and analyzing the data. All the solutions we now have, like Internet of Things, AI, would be nothing if there was no data to support them. In the pursuit of knowledge, data are a collection of discrete values that convey information describing quantity, quality, fact, statistics, other basic units of meaning, or simply sequences of symbols that may be further interpreted. A datum is an individual value in a collection of data. In other words, data is a collection of facts such as numbers, words, measurements, observations, or just descriptions of things. There are two types of data. One is qualitative and other is quantitative data. Qualitative data is descriptive information that can describe something, and qualitative data is numerical information. Data is now easier to collect and cheaper to store, making it accessible to nearly every business. Data solutions include software technologies and platforms that can help facilitate the collection, analysis, and storage of valuable information. Every business would like to grow their revenues and make larger profits. In this competitive market, data is a valuable asset. When analyzed properly, data provides a wealth of useful information and inform critical business decisions. We know that data is a collection of facts such as numbers, descriptions, and observations used to record information. The process of organizing the data of a company with representing entities is called data structures. Let's consider a sales management system of the company. In this case, customers, products, sales orders, etc. can be entities. Each entity typically has one or more attributes or characteristics and can be relation among entities. For a customer entity, attribute can be name, address, phone number, and so on. Similarly, for a product entity, attribute can be name, quantity, and price. In the purest sense, a data format is the arrangement of data fields for specific shape. Let's consider another example to make it more clear. In an employee management system, employee company can be entity with the attribute of name, designation department for employee and name, address, contact for company entity. I hope you have got an idea of data format. On the basis of data format, data can be classified into three: structured data, semi-structured data, unstructured data. Structured data is data that adheres to a fixed schema, so all of the data has the same fields or properties. Most commonly, the schema for structured data entities is tabular. In other words, the data is represented in one or more tables that consist of rows to represent each instances of a data entity and columns to represent attributes of the entity. In other words, structured data is when data is in a standardized format, has a well-defined structure, complies to a data model, follows a persistent order, and is easily accessed by humans and programs. This data type is generally stored in a database in which multiple tables can reference one another by using key values in a relational model. In order to make it clear, let's consider an example where the tabular data representations for customer and product entities. Let's consider the customer entity that has the attribute of ID, first name, last name, email, and address. Here the first column represents the ID attribute of the customer entity. Second column represents the first name attribute of the customer entity, and so on. Semi-structured data is information that has some structure but which allows for some variation between entity instances. For example, while most customers may have an email address, some might have multiple email addresses, and some might have none at all. One common format for semi-structured data is JavaScript Object Notation (JSON). The example below shows a pair of JSON documents that represent customer information. Each customer document includes address and contact information, but the specific fields vary between customers. In other words, semi-structured data is data that does not conform to a data model but has some structure. It lacks a fixed or rigid schema. It is the data that does not reside in a relational database but that have some organizational properties that make it easier to analyze. With some processes, we can store them in the relational database. Email data is the semi-structured data. The data which is not structured or even semi-structured is called unstructured. Documents, images, audio, and video data and binary files are the example of unstructured data. This kind of data is referred to as unstructured data because it has no any structure or semi-structure. In simply, unstructured data is information that is not earns according to a preset data model or schema, and therefore cannot be stored in a traditional relational database or RDBMS. We know that data format can be classified into three: structured data, semi-structured data, and unstructured data. Data can also be stored in structured, semi-structured, and unstructured so that it can be retrieved from analysis and reporting later. There are two broad categories of data stored in common uses: file stores, databases. In a computing system, data can be stored in files, and files can be stored in local file systems on the hard disk of your personal computer and on removable media such as USB drives. But in most organizations, important data files are stored centrally in some kind of shared file storage system. Increasingly, that central storage location is hosted in the cloud, enabling cost-effective, secure, and reliable storage for large volumes of data. Data can be stored in a file in different file formats such as delimited text files, JavaScript object notation, JSON, extensively markup language, XML, binary large object blob, optimized file format. The specific file format used to store data depends on number of factors, including the type of data being stored, structured, semi-structured, or unstructured, the applications and the services that will need to read, write, and process the data, the need for the data files to be readable by humans or optimized for efficient storage and processing. Delimited text file. The most common format for delimited data is comma separated value CSV, in which fields are separated by commas and rows are terminated by a carries return new line. Optionally, the first line may include the field names. Other common formats include tab separated values TSV and space delimited, in which tabs or spaces are used to separate fields, and fixed width data, in which each field is allocated a fixed number of characters. Delimited text file is a good choice for structured data that needs to be accessed by a wide range of applications and services in a human readable format. First name, last name, email: Joe Jones, Joe @litwar.com. Samir Narboy, Samir @northwind.com. JavaScript object notation JSON. JSON is a ubiquitous format in which a hierarchical document schema is used to define data entities, objects that have multiple attributes. Each attribute might be an object or a collection of objects, making JSON a flexible format that's good for both structured and semi-structured data. The following example shows a JSON document containing a collection of customers. Each customer has three attributes: first name, last name, and contact. And the contact attribute contains a collection of objects that represent one or more contact methods, email or phone. Note that objects are enclosed in brackets and collections are enclosed in square brackets. Attributes are represented by name, value pairs, and separated by commas. Extensible markup language XML. XML is a human readable data format. It's largely been superseded by the less verbose JSON format, but there are still some systems that use XML to represent data. XML uses tags enclosed in a angle brackets to define elements and attributes. Binary large object blob. Ultimately, all files are stored as binary data, ones and zeros. But in the human readable formats, the bytes of binary data are mapped to printable characters through a character encoding schema such as ASCII or Unicode. In case of unstructured data file formats, data is stored as raw binary that must be interpreted by applications and rendered. Common types of data stored as binary include images, video, audio, and application-specific documents. Optimized file formats. In order to optimize the storage space or processing of human readable formats for structured and semi-structured data, some specialized file formats including OVRO, ORC, and Parquet that enable compressions, indexing, and efficient storage and processing have been developed. OVRO OVRO is a row-based format. It was created by Apache. Each record contains a header that describes the structure of the data in the record. This header is stored as JSON. The data is stored as binary information. An application uses the information in the header to parse the binary data and extract the fields it contains. OVRO is a good format for compressing data and minimizing storage and network bandwidth requirements. ORC optimized row column format. ORC optimized row column format organizes data into columns rather than rows. It was developed by Hortonworks for optimizing read and write operations in Apache Hive. Hive is a data warehouse system that supports fast data summarization and querying over large data sets. An ORC file contains stripes of data. Each stripe holds the data for a column or set of columns. A stripe contains an index into the rows in this stripe, the data for each row, and a footer that holds statistical information, count, sum, max, min, and so on for each column. Parquet is another column data format. It was created by Cloudera and Twitter. A Parquet file contains row groups. Data for each column is stored together in the same row group. Each row group contains one or more chunks of data. A Parquet file includes metadata that describes the set of rows found in each chunk. An application can use this metadata to quickly locate the correct chunk for a given set of rows and retrieve the data in the specified columns for these rows. Parquet specializes in storing and processing nested data types efficiently. It supports very efficient compression and encoding schemas. A database is an organized collection of related data from which you can easily retrieve and use data. In other words, a database is a structured information collection that is often kept electronically in a computer system. A database is used to define a central system in which data can be stored and queried. Relational database. Relational databases are commonly used to store and query structured data. The data is stored in tables that represent entities such as customers, products, or sales orders. Each instance of any entity is assigned a primary key that uniquely identify it, and these keys are used to reference the entity instances in other tables. Here, a customer's primary key, named ID, can be referenced in a sales order record by the column customer to indicate which customer placed the order. This use of keys to reference data entities enables a relational database to be normalized, which in part means the elimination of duplicate data values so that details of an individual customer are stored only once, not for each sales order the customer places. The tables are managed and queried using structured query language SQL, which is based on an ANSI standard, so it's similar across multiple database systems. Non-relational databases are data management systems that don't apply a relational schema to the data. Non-relational databases are often referred to as NoSQL database, even though some support a variant of the SQL languages. There are four common types of non-relational database commonly in use. Key value databases. Key value database in which each record consists of a unique key and an associated value which can be in any format. Document databases. Document database which are a specific form of key value database in which the value is a JSON document which the system is optimized to parse and query. Column family databases. Column family databases which store tabular data comprising rows and columns, but you can divide the columns into groups known as column families. Each column family holds a set of columns that are logically related together. Graph databases. Graph databases which store entities as nodes with links to define relationships between them. A transactional data processing system is considered as a primary function of business computing. A transactional system records transactions that encapsulate specific events that the organization wants to track. A transaction could be financial, such as the movement of money between accounts in a banking system, or it might be part of a retail system, tracking payments or goods and services from customers. Think of a transaction as a small, discrete unit of work. Let's consider a point of sale POS system. Here the transactional data is usually recorded at the point of sale. Transactional data is nothing but an information that is captured from transactions. It records many information including the time of the transaction, the place where it occurred, the price of the items, the payment method employed, discounts if any, and other quantities and qualities associated with the transaction. Transactional systems are often high volume, sometimes handling many millions of transactions in a single day. The data being processed has to be accessible very quickly. The work performed by transactional system is often referred to as online transactional processing (OLTP). Online transactional processing (OLTP). Online transactional processing is defined as work performed by transactional systems. OLTP solutions rely on a database system in which data storage is optimized for both read and write operations in order to support transactional workloads in which data records are created, retrieved, updated, and deleted, often referred to as CRUD operations. In simply, we can say if the data storage in a database system is optimized for both read and write operations for supporting the transactional workloads, this database system must be reliable for OLTP solutions. Here, transactional workloads encapsulate the operations of data creating, retrieving, updating, and deleting. These operations are applied transactionally in a way that ensures the integrity of the data stored in the database. To accomplish this, OLTP systems enforce transactions that support so-called semantics atomicity. Each transaction is treated as a single unit which succeeds completely or fails completely. For example, a transaction that involves debiting funds from one account and crediting the same amount to another account must complete both actions. Consistency. Transactions can only take the data in the database from one valid state to another. To continue the debit and credit example above, the completed state of the transaction must reflect the transfer of funds from one account to other. Isolation. Concurrent transactions cannot interfere with one another and must result in a consistent database state. For example, while the transaction to transfer funds from one account to another is in process, another transaction that checks the balance of these accounts must return consistent results. The balance checking transaction cannot retrieve a value for one account that reflects the balance before the transfer and a value for the other account that reflects the balance after the transfer. Durability. When a transaction has been committed, it will remain committed. After the account transfer transactions has completed, the revised account balances are persisted so that even if the database system were to be switched off, the committed transaction would be reflected when it is switched on again. Analytical data processing typically uses read-only or read-mostly systems that store vast volumes of historical data or business metrics. Analytics can be based on a snapshot of the data at a given point in time or a series of snapshots. The specific details for an analytical processing system can vary between solutions, but a common architecture for enterprise-scale analytics look like this. 1. Data files may be stored in a central data lake for analysis. 2. An extract, transform, and load ETL process copies data from files and OLTP databases into a data warehouse that is optimized for read activity. Commonly, a data warehouse schema is based on fact tables that contain numeric values you want to analyze, for example, sales amounts, with related dimension tables that represent the entities by which you want to measure them, for example, customer or product. 3. Data in the data warehouse may be aggregated and loaded into an online analytical processing OLAP model or cube. Aggregated numeric values measures from fact tables are calculated for intersections of dimensions from dimension tables. For example, sales revenue might be totaled by data, customer, and product. 4. The data in the data lake, data warehouse, and analytical model can be queried to produce reports, visualizations, and dashboards. Data lakes. Data lakes are common in large-scale data analytical processing scenarios, where a large volume of file-based data must be collected and analyzed. Data warehouses. Data warehouses are an established way to store data in a relational schema that is optimized for read operations, primarily queries to support reporting and data visualization. The data warehouse schema may require some denormalization of data in an OLTP data source, introducing some duplication to make queries perform faster. An OLAP model. An OLAP model is an aggregated type of data storage that is optimized for analytical workloads. Data aggregations are across dimensions at different levels, enabling you to drill up down to view aggregations at multiple hierarchical levels. For example, to find total sales by region, by city, or for an individual addresses. Because OLAP data is pre-aggregated, queries to return the summarize it contains can be run quickly. Review. Data format. A data format is the arrangement of data fields for a specific shape. Structured data. Structured data is when data is in a standardized format, has a well-defined structure, complies to a data model, follows a persistent order, and is easily accessed by humans and programs. Semi-structured data. Semi-structured data is data that does not conform to a data model but has some structure. Email data is the semi-structured data. Unstructured data. The data which is not structured or even semi-structured is called unstructured data. Documents, images, audio and video data and binary files are the example of unstructured data. This kind of data is referred to as unstructured data because it has no any structure or semi-structure. Delimited text file. The most common format for delimited data is comma separated value CSV, in which fields are separated by commas and rows are terminated by a carriers return new line. JavaScript object notation JSON. JSON is a ubiquitous format in which a hierarchical document schema is used to define data entities objects that have multiple attributes. Extensible Markup Language XML. XML is a human readable data format. It's largely been superseded by the less verbose JSON format, but there are still some systems that use XML to represent data. Binary large object blob. Ultimately, all files are stored as binary data, ones and zeros, but in the human readable formats, the bytes of binary data are mapped to a printable characters through a character encoding schema such as ASCII or Unicode. In case of unstructured data file formats, data is stored as a raw binary that must be interpreted by applications and rendered. Common types of data stored as binary include images, video, audio, and application-specific documents. Optimize file format. In order to optimize the storage space or processing of human-readable formats for structured and semi-structured data, some specialized file formats, including OBRO, ORC, and Parquet, that enable compression, indexing, and efficient storage and processing have been developed. Relational database. Relational databases are commonly used to store and query structured data. The data is stored in tables that represent entities. Each instance of an entity is assigned a primary key that uniquely identifies it, and these keys are used to reference the entity instance in other tables. Non-relational database. Non-relational databases are data management systems that don't apply a relational schema to the data. Non-relational databases are often referred to as NoSQL database, even though some support a variant of the SQL languages. Key value database. Key value database is non-relational database in which each record consists of a unique key and an associated value which can be in any format. Document database. Document database is non-relational database which are a specific form of key value database in which the value is a JSON document. Column family database. Column family database is non-relational database which store tabular data comprising rows and columns, but you can divide the columns into groups known as column families. Each column family holds a set of columns that are logically related together. Graph database. Graph database is a non-relational database which stores entities as nodes with links to define relationships between them. Transactional data processing. A transactional data processing system is considered as a primary function of business computing. A transactional system records transactions that encapsulate specific events that the organization wants to track. Online transactional processing. Online transactional processing is defined as work performed by transactional systems. Analytical data processing. Analytical data processing typically uses read-only or read-mostly systems that store vast volumes of historical data or business metrics. Analytics can be based on a snapshot of the data at a given point in time or a series of snapshots. Thank you for watching this tutorial. I hope you all have been able to take the idea about the core data concepts. If you think this tutorial is helpful for learning the Azure Data Fundamentals, please click on the like button and request you all to share it more and more to the persons who are searching the tutorial like this. If you have any questions on this tutorial, opinions and queries about this channel, please type these in the comment box. You also mail to me. In the description box, email ID is given for you. Kindly subscribe this channel and click on the bell button so that you can get notification when new tutorial is published.